Hi folks, Mr. Ackerman here. Thanks for watching. This is your first supplementary video and it's for Unit 3, Lesson 1. So in Google Class, in the stream, you'll see Unit 3, Lesson 1 has been posted. It was actually posted prior to the March break for those of you who wanted to work ahead, but I've now moved it to the top of the stream and the dates in there reflect the fact that we're going at about half the regular pace. So this is from Monday, April 6th to Tuesday, April 7th. You'll see at the moment I have my regular video, which you're going to watch, and here are the lecture notes. After I record this video, I'll put it in there as well, and so while you're watching this, you're going to see a slightly different screen. Anyway, assuming you've already watched this video and you're now watching this one, you've downloaded the lecture notes. Let's go through them. Let's pretend that we are in class. So this is what you're going to be seeing in your lecture notes, and it was covered in the video. I'm just going to go through a few quick things. What is uniform circular motion? You're going to remember that we're talking about constant speed and radius for an object moving in circular motion. And because the direction and the direction of the velocity vector keeps changing, therefore there's acceleration. You learned in the video that that acceleration points inward toward the center, and a word for that is centripetal. So we call it centripetal acceleration, and we give it the symbol AC. More information, obviously, in the original video. Go watch that. I'm going to move quickly here. So, on the next lecture note page, you're going to see that a formula for centripetal acceleration is this, v squared over r. And again, that's explained in the video, which you were supposed to have watched. So this gives you the magnitude. You know the direction is in toward the center, but there's a few other formulas that can be used. If we use the idea that the circumference of a circle is 2 pi r, and that the time needed to go in a circle that is repeating is also known as the period t, we can come up with a few other formulas. 4 pi squared r f squared, or 4 pi squared r over t squared are additional formulas that can be used. When you get to the third page of the lecture notes, you're going to see a practice problem that involves the planet Mercury going around the sun. And this one is fairly straightforward, so I'm going to let you give it a try. And remember, if you, when you finish it, you're going to check the solution manual and see if you made a mistake. If you made a mistake, you're going to correct it. And if you are still stuck and you don't understand the solution, then you're going to email me or add a class comment, or maybe somewhere down the road you'll have chat room open, and that could be a possibility. But in any case, this one's pretty straightforward. Just one thing to point out, it asks for an answer in terms of a unit called Earth days. What do we mean by Earth days? We mean the Earth rotates once every 24 hours, so just remember that. And so you can convert that into seconds and therefore give your answer in terms of Earth days. Now there's something kind of interesting down here with Mercury, and I wanted to talk to you about this because as you look at this in the lecture notes, you're going to wonder, like, what the heck is this? Some fun with Mercury. It's not in the textbook, and I'm not sure that I explained it in the original video. I don't think I did. So let's take a look. As you know, Mercury is the first planet out from the sun, and it orbits pretty rapidly and on a bit of an elliptical or oval-shaped path. Now, Mercury, it comes closest to the sun at a certain point in space, and we call that the perihelion. Every planet, because of its elliptical orbit, has a distance of closest approach called perihelion. But when we use Newton's physics, you know, gm1 m2 over d squared for the force of gravity, which is responsible for this motion, it predicts that the perihelion point is going to be at a certain point in space. And it's actually not static. It does move around a little bit because there's more than just Mercury and the Sun in the solar system. There's other planets pushing and pulling at different, well, pulling rather, at various different times depending on where they are in their orbits. Like Jupiter pulls, Earth pulls, Mars pulls, And that causes the perihelion point to move, as you can see in this diagram. You see point 1, 2, 3, 4. Every year it moves ever so slightly. Well, Newton's physics predicts that it'll be in a certain place, but Newton's physics never quite gives the right answer. And so it wasn't until Einstein came up with his general theory of relativity, I think in 1916, about 100 years ago, that scientists now had a tool to look at gravity in a slightly new way, and they found out that now they could explain Mercury's perihelion movement, or precession as it's called, much more accurately. And this is considered a very good test of Einstein's general theory of relativity. If you think back to when we did special relativity, we talked about how muons created high in the Earth's atmosphere. Remember, they kind of rain down, and because of time dilation, they're able to make it to the surface of Earth. If you remember that, that was a test of special relativity. Well, now we've got a test of general relativity, which is related to special relativity, but it's very complex, and it deals with gravity and space-time and all sorts of things that we don't really talk about in this course. But I just thought it was a cool connection to this question here that you were doing, 10 on 126. Well, here's another example for you. So if you want to look up more about that, look at Mercury and the precession of its perihelion point. We finish up with a question number 11 on 126, and this one I'm just going to go through really quickly with you because it may throw some of you. So let's take a look. Graph the relationship between the magnitude of centripetal acceleration and A, B, C, three different things. So the first one is, let me just find what I need here. I've got to move that down a little bit. And I need that. I'm going to make a little graph because that's what they asked for. And they want the relationship between centripetal acceleration, so AC goes on the vertical axis, and in A, the speed of an object in uniform circular motion with a constant radius. So what you're supposed to do here is think back to the formula that contains all the letters you see here. There's AC and there's V. So the formula V squared over R has that. You don't want to use this one because it doesn't have V in it, and you don't want to use this one for the same reason. Okay, so don't use those for this question. Use this one. It says, imagine the radius being constant, and so this is kind of like, I don't know, pick a number if it bothers you seeing a letter there. Example, I don't know, 10. So imagine you had a formula that said AC equals V squared over 10. This is kind of like y equals x squared over 10, isn't it? The y is like the AC, the x is like the v. So what would this thing look like? You see it's a parabola. So what they're looking for here is for you to draw a parabola. And you do the same thing for B and C, and that's what this question is all about. All right? You've got a couple days to work on this and try to practice problems in the unit schedule. And once you do that, if you have any questions, you know that you can come and ask me, right? While we're on the topic of the unit schedule, I've just paused the video briefly and then I brought up the unit schedule. Remember, it's in the course pack. You should be looking at this, especially these days. And you'll remember, here we are, lesson 1 for unit 3. Practice problems you would normally be trying in class. Some of these might be in the lecture notes, some might not. After class extra problems. To make sure you are getting the most out of this, you should next go to the learning goals and success criteria here. These are a good check to make sure you're understanding what is expected of you. And that's it for now. So I hope this works out well for you. If you have any questions, you let me know and we'll deal with it. Okay guys, thanks for watching and have a great day.